Hello and welcome to another exciting quest in our journey through the world of mathematics. We are told that Mount Everest is 5,895 meters high. But how was this height determined? Did somebody climb to the top of the mountain and then extend a giant tape through the mountain down to its roots? We are also told that the Pacific Ocean extends to a depth of 10,911 meters. Again we ask, how was this depth determined? Did somebody sail to the middle of the ocean and then extend a giant tape through the ocean down to its bottom? Similarly, we often hear about the height, depth, or even length of certain structures, and we wonder how this was done. Welcome to trigonometry. The word trigonometry is gotten from two Greek words, trigonon meaning triangle and metron meaning measure. Trigonometry is a branch of mathematics that studies relationships between sides, lengths, and angles of triangles. Scientists have noted that the ratio of the lengths of two sides of a right-angled triangle depends only on one acute angle of the triangle. These dependencies are now called trigonometric functions. From our previous lesson on right-angled triangles, we have learned that if one angle of a triangle is 90 degrees and one of the other angles is known, the third is thereby fixed because the three angles of any triangle add up to 180 degrees. The two acute angles therefore add up to 90 degrees. This means that they are complementary angles. I hope you have not forgotten that complementary angles are angles that add up to 90 degrees. The shape of a triangle is completely determined except for similarity by the angles. Once the angles are known, the ratios of the sides are determined regardless of the overall size of the triangle. If the length of one of the sides is known, the other two are determined. Therefore, given the right-angled triangle on your screen, these ratios are given by the following trigonometric functions of the known angle labeled with capital letter X, where small letters A, B, and C refer to the lengths of the sides of the accompanying figure. The longest side C is called the hypotenuse. It is the side opposite to the 90-degree angle in the right-angled triangle. The side opposite the angle of reference X is labeled A, and it is called the opposite. The third side is called the adjacent because it is adjacent to the angle of reference. There are three trigonometric functions which we will learn about in this lesson. They are the sine, the cosine, and the tangent functions. The sine function is defined as the ratio of the opposite to the hypotenuse. We shall call this SO, which is a short way to help us remember that sine is opposite over hypotenuse. The cosine function is defined as the ratio of the adjacent to the hypotenuse. We shall call this CA, which is our short way of remembering that cosine is adjacent over hypotenuse. Lastly, the tangent function is defined as the ratio of the opposite to the adjacent. We shall call this TOA to help us remember that tangent is opposite over adjacent. So the general term to help us remember definitions for all the three trigonometric functions is SOHCAHTOA. Students usually misunderstand or confuse the opposite and adjacent sides of a right-angled triangle. They usually think the opposite is always the vertical side of the triangle, while the adjacent is always the horizontal or base. This is not always true. In fact, it is a wrong way of understanding the idea. The correct understanding is that there must first be an angle of reference. For example, the angle labeled X in our triangle on the screen. The side opposite to this angle is the opposite, while the side adjacent to it is the adjacent. If, for instance, our angle of reference X becomes the other angle in the triangle as shown on the screen, then the opposite and the adjacent will also swap as in the illustration. The side opposite the angle X is still the opposite, and the side adjacent to it is still the adjacent. So, always watch out to first identify the angle of reference. Then, the side opposite to it will be the opposite, and the other side, which is not the hypotenuse, will be the adjacent. It is usually very easy to identify the hypotenuse. The hypotenuse is always the longest side of the triangle and usually never confused. It is the side always opposite to the 90-degree angle of the right-angled triangle. As we dive deeper into this chapter, You must always remember what we learnt in this lesson, as they will come in very handy and useful. In subsequent lessons, we shall be learning how to apply these trigonometric functions to solving right-angled triangles. Don't give up and stay focused. Bye for now.